again in a minute. Hey everyone, welcome back. We're now heading into session 2. This session is called Build AI First Apps with Semantic Kernel, and we are going to be joined by Arafat Tehsin, who is a Microsoft MVP in AI and also a software consultant. Hello, how are you doing?
Very well, how are you?
Very good. We're on to our second session. I'm actually very excited for this session, Arafat. You've got a bit of a challenge for me. Semantic Kernel, I have a gentleman in my team who knows like everything about it, and I feel like we have really good conversations, but I need you to like skill me up a little bit more, and I feel like your session's going to be perfect for it, so I'm very excited. But tell us a little bit more, tell the audience a little bit more about what you're going to talk about.
Yeah, I'm going to talk about all about AI first apps. So what AI first apps are and how you can really use Semantic Kernel as an orchestrator to build AI applications for yourself. So everybody can be an AI developer today.
Nice. And I gave you a very brief introduction. I feel like you could tell us more about yourself. What do you do? What do you do day to day?
Yeah, absolutely. So I'm a senior manager at EY and a Microsoft MVP for artificial intelligence. I'm usually based in Sydney, but today I'm joining you from my home city, Karachi, and where I grew up, and my parents live here. So one of the cities that never sleeps. Yeah.
Or is it just an RN? Don't worry. Technical difficulties are totally normal for live streams. We're good. Can you?
Can you hear me?
Yes.
Yeah, now we can hear you again.
Fantastic.
Yeah.
Sorry about that. Yeah, we live and we learn, don't we, from our technical difficulties. Anyway, we won't take any more time from you to make sure that you get all of that great content in, and we'll be here at the end to hopefully ask you a couple of questions as well. So are you ready? Do you want to take it away?
Absolutely. All right, everybody, thank you so much. In our next 25 minutes, we are going to learn all about AI first apps. So I wanted to give in my introduction. Let me just make my presentation in the presentation mode so that it becomes easier for everybody. So my name is Arafat Tehsin, and I'm joining you from, as I said, from Karachi. I'm usually based in Sydney, but just visiting my parents over here. So I thought that why not giving a talk from this side. So in our next 25 minutes, we'll be learning all about AI first apps, what they are and how Semantic Kernel plays an important role in it. We will also have a look at the ways to learn all about this technology in a fun way, which will enable you to build some good experiences. So moving on to our discussion, you must have seen all of these applications, right? So you can see that the AI, whether you're learning and interacting, sharing, or just doing any other things, you see that all of the applications you use in your daily life. So the most common thing of this whole set of applications is the infusion of artificial intelligence. And all of these apps are using AI for some kind of their operations, from user experiences to decision making to production. Therefore, we are going to talk about the AI first apps, which are the apps which are using artificial intelligence as their core technology or the functionality. They are built for better user experiences, repetitive tasks, automating the repetitive tasks, presenting you the right content, and so much more. So AI first apps are not new, but with the advent of ChatGPT, it has changed the way we develop apps. The accessibility of large language models has taken the internet by storm. As someone who has been building chatbots for like many years, I can safely say that the conversational apps, which used to take months, now take just a few days to deliver. Not just chatbots, individuals, startups, or even large enterprises are infusing these LLM capabilities into various types of applications like grocery shopping, services, streaming ride, and so on. Now, moving towards this, if we see that the Facebook, the amount of the time which Facebook took to reach to a place, it has been um, the amount of Facebook it reached to reach over the sorry, just yeah, the amount of time Facebook took, it just took ChatGPT 2 months to reach over there. Now, let's talk about what is the traditional machine learning model looks like and what is the cycle. So traditionally, the cycle of the machine learning is a little lengthy. How it is lengthy? So you see that there is a resource and time consuming for even smaller projects. We are not whether you're not doing any complex work. For example, we are doing just house predicting prices, or we are just predicting whether the person is eligible for the car loans or not. Even for that kind of operations, we see that there is a tedious process of machine learning development, which has now been changed. So regardless of your developer experience, whether you are a Java developer, Ruby developer, or any developer, AI just is an API away. You can create some fantastic solutions using these APIs, for example, OpenAI APIs. Now, in order to build these systems, you have got broadly two options. There are two ways to use this as a core of your AI app. One way is to create your own wrappers for the exposed LLM APIs, let's say for OpenAI, for Azure OpenAI, Hugging Face, and all other models, and then consume them into your applications. The other way is to use some kind of SDKs. Now, the problem with the first one is the reliability and scalability really depends upon your application. So if it is a simple app that takes an input, processes it, and returns an output, then this approach may suit your needs. Whereas for the second approach, you do not have to take care of the underlying architecture of how the information is being processed, the target schema, and much more. So all you have to do is to focus on your logic. This way, you will have a better time to achieve your goal. And one of the tools to achieve this is basically semantic kernel. So what is semantic kernel? Microsoft semantic kernel can be considered just for everybody who's not aware of like what semantic kernel is, what AI orchestration is. So semantic kernel can be considered as a big box of Lego blocks. Each block represents a different AI service, like understanding language, answering questions, or even creating an art. As a developer, you can pick and choose which blocks you want to use to build your application, just like you would build a Lego model. You can combine these blocks in any way you want to create something. The best part of semantic kernel is that it is open source, so you can just fork it, create your own stuff, or connectors, as they say. This means that not only you can use all of these blocks for free, but you can also create your own blocks. Semantic kernel has a lot of components, or you can say building blocks. And one of the main building blocks are AI plugins. So what are AI plugins? So AI plugins are basically the set of instructions or tasks that that you can use in your application to perform certain tasks. You can think of them as a recipe book for your application, like whole plugin as a recipe book. So each recipe or a plugin can contain the list of ingredients or functions and steps, which are triggers or actions that your application can use to accomplish a specific task. For example, you want to build a chatbot and you want to be able to answer questions about weather. So you can create a plugin that contains a function for fetching the weather data from the API. Another function can be formatting the data into a user-friendly message. So this way, to sum it up, the plugins are basically the fundamental building blocks. And you can see that in this image, I've shown the image for Microsoft 365, ChatGPT, and Bing. Semantic kernel is basically the brain of all of that. So the orchestration is happening within semantic kernel. Same way you can also create your own applications. Now, talking about a little further of semantic function, like what semantic function is. So plugins have got two types of functions, right? One of them is semantic function. think of semantic function as the individual step in the recipe. So each step tells your application what to do and how to do it. For example, let's say you are building an app, building a chatbot again, and you want to answer, each plugin has got multiple semantic functions and each can be triggered by certain events. We'll see a example of it. So if I'm being too theoretical about it, please don't mind about it, but we'll see it in an action. This way you will definitely get more better understanding on that. So this image actually shows that it is the ears and lips for your LLM or for your application. So if you are building an application, you want to have some cool AI features in it, semantic functions within semantic kernel gives you all of that. I know it's the confusing, names are confusing, but that's how it is. Moving to the native functions. So what are native functions? So native functions are actually the tools you use when you are following that recipe. So for example, let's say think of native function as the tools as I said. So let's say you are building a chatbot and you are one of the recipes plugins for baking a cake. So one of your steps, which is semantic function, might be to mix the ingredients with together, and that mixing can be done with native function like a blender. So just like cooking, having the right tools make all the difference. That's why semantic kernel allows you to create your own native function so that you can have the right tools for calculation, for finding out the right outcome, shortest distance, and all that. So and again, as I said, we'll talk about it. But before we get into the actual showcase of that, I want to show a little more easier version of my explanation as how what I have built for you to understand it better in a easier way. Now I have built an app um, that's called a Guess What app, which I built for educational purpose so that you can learn all about AI first app using the powerful orchestration of semantic kernel. The app's name is Guess What. So this is the app, a cross-platform app built using .NET MAUI, and it has got a semantic kernel as their backbone. What does it do? So it has got riddles and the landmarks. So it generates the riddles using LLMs, and it also generates the description of landmarks, images, and then lets you guess it. So these riddles and landmarks, as I said, generated by AI, all powered by semantic kernel using Azure OpenAI or OpenAI models. So I've given a privilege to use either of them. You can see that in a simplest architecture, which I've shown in the screen on the screen, it has got a plugin with two semantic functions, get riddle and get landmark. So essentially, I've got just one plugin, two semantic functions, get riddle, get landmark. It also has got one native function, which is cosine similarity, which returns the score of cosine angle. Someone can ask me that, what is this? Don't worry, we will also, I've tried to explain this in the easiest possible manner in the future slides. So just give me like 5 more minutes or 3 more minutes and we will go to that. So now if you see this, the GIF image over here, you can see that app lets you, the way app works over here, that is you choose the get riddles and it generates the riddles for you. And if you choose the landmarks and choose the country, it generates the landmark of that country, a famous landmark, and then it lets you guess it. So this is basically the idea of creating this application, just to show like how you can use very easily all of these AI capabilities into your application and make your app as an AI first app. Now, I know that we discussed about cosine similarity and all of that, like how does it actually work? How does it actually matches? So let's talk about the first concept as embeddings. And as I said that I will not spend too much time of it. So just 2 or 3 more minutes, and then we will jump onto the demo part or the hands-on part where you can learn something and you can also try something rather than just me speaking, blah, blah, blah. So Let's talk about embeddings. So embeddings, you can see that, we all know that computers don't understand words and sentences as we humans do. So we need to convert we need a way to convert our text data into numerical format that a computer can work with. That's where embeddings come in, right? And embeddings take a word or a piece of text and maps it into high dimensional vector of real numbers. So what you see as on the right side of the screen, that the right side, there's a vector. The interesting part of these vectors are created in a way, such a way that the words with similar meanings are placed together in this high dimensional space. This allows machine learning models to understand the semantic similarity between these two words or pieces of text. So now if you see closely that, for example, the word cat and kitten could be mapped to vectors that are closer to each other in the embedding space because they have similar meanings. On the other hand, the word cat or car would be mapped to vectors which are further apart because they are semantically different. Right now, that's fine. We got this idea. Now people are the embeddings are placed in the high dimensional space, but how they are matched, what is the cosine similarity? So the last concept of today, before we get into the action, is cosine similarity is the way of comparing two things. But instead of comparing them directly, we compare the direction where they are heading. So imagine you and your friend are going to a trip, uh, and you are starting from the same place, but you might not go to the same destination. So you are starting from the same site, but you may not go to the same destination. So the cosine similarity is the measure of how similar your destination are on the basis of where you are heading. So in terms of vector, which you can think of arrows pointing from one point to another, the cosine similarity is calculated by taking the cosine angle between two vectors. So if the vectors are pointing exactly in the same direction, the angle between them would be 0, and their cosine similarity is like 1, which is like 100% matching. If they are pointing into opposite direction, it would be 180-degree, and their cosine similarity would be like -1. So things like that. And in programming or data science, we often use cosine similarity to compare different pieces of data. For example, if we have got like two documents, we want to see how similar they are. We can represent each document as a vector and then find out the similarity between them. So I think this was the stuff which I wanted to show. Now we will see like how they are actually matched over here. How can you build this application? So let's get into the demo part of it, and I will try to share my screen. So I am going to share my screen again, and this time I'm gonna share my, not this one. So this one. So this is the semantic kernel. Um, this is my semantic kernel notebook. How do you get it as someone? So I've already written a good blog post about it, like what is this, how I built this app. If you want to know about it, you can also have a look at the repo. My GitHub link, I'll post it in the chat. And hopefully somebody else will be able to grab it from the team, and then they will be posting it on the YouTube as well. So you will get it, and if you don't, please contact me and I'll give it to you. So it has got the notebooks of sample semantic kernel and also Azure OpenAI if you are just starting it with the Azure OpenAI service. So if you go to semantic kernel, you will see the .NET semantic kernel notebook. I'm working on Python one. I haven't got a chance yet. So if you are someone from Python, please, and you want to contribute, please feel free to fork it and submit it. You can literally just copy what I've written over here. So this is the polyglot notebook for semantic kernel. Very basic stuff. We start from this mic check, and then I've already loaded my Azure OpenAI keys. So if you have not loaded it, it will ask you, it will prompt you. And then I've written all the descriptions which I've talked to you about so that you don't get surprised, like what is semantic kernel, blah, blah, blah. And now we are just loading the semantic kernel. Because of I'm conscious of time, that's why I'm trying to go a little faster. If you think that if you've got any questions, I'll be definitely answering all of those questions at the end. So please don't worry about it. You can reach out to me anytime, even if you think that your questions has not been answered. Again, the same explanations which I explained to you about, I've just written them over here as well. So now we will build a first plugin over here, or you can say a first semantic function. It's as easy as creating a new context kernel. So no, sorry, new kernel. So you must have seen that we have just set up a kernel over here with the semantic kernel. So we have created one kernel, initialized the kernel. We have set up the services over here. After setting up the service, we are just setting up one function. How do you call these functions? How do you build these functions? So if you see this, I am calling the function, my semantic function, which is a part of the plugins directory in the city plugin. So if I go inside city plugin, you can see that this is the configuration of my city plugin, and this is the prompt which I am going to get. So tell me a capital of a country below, and in the input parameter, I am giving the input as Portugal. So if I run this, you will see the answer of the capital city of Portugal is Lisbon. So now if anybody is joining from Portugal, definitely know, but most of us, many of us may not know. So I'm now changing it to Australia, let's say, and if I run this again, and it would give me that the capital of Australia is Canberra. Now, the same way I used it to build the riddle for this app as well. Now, how did I build this? So again, another plugin called Guest plugin. I have got the similar kind of configuration, gets the riddle and an answer in a JSON format. And in my SK prompt, I said, ask a riddle with its answer and give me in a below format. Now, going back, if I run this, you can see this whole code can be accessible from the notebook, but I'm just running it, and it will generate a riddle which has got what has keys but can't open, and it is also giving me an answer because I've got an answer over here. If I wanted to see like what riddle object was there, I would have just gone console.writeline and did it. But with the conscious of time, I just have 4 minutes. So I just wanted to show you 2 more examples and then we'll wrap it up. You could see that I've taken the examples from the file over here. So it is not inline functions, it is file-based functions. Now, I have also given an inline function example because .NET MAUI works with inline functions. It does not work with the file system because .NET MAUI is a cross-platform application. It gets a little tricky when you talk about the inline file-based functions. So same example, but in a syntax of the inline function mode. So you can see that I've asked it to generate some riddle and also the answer of it, and it has created a riddle about Apple, and it has given me an answer. If I and at the same time, I was after that last example over here is with the generative AI images. So with Dolly, we are creating the image about what? Image about Australia. So if I go and show you the guess what prompt, choose a landmark in a big city with an input, which is Australia, which I'm going to give. Remember that it has to be famous with at least known landmark. The input has to be in terms of history, culture, and tourism. So if I run this, you will see that it is going to create an image from DALL-E 2 of an Australia because I have given Australia as an image over here, right? Now it has generated an image of the Opera House. Now, if I want to match it, like what is my description against the description of what has been generated by AI, I would use cosine similarity. So if I go down and if I click on this piece of code, it will ask me describe the image in your words, and I will say Sydney Opera House. So if I write this, it will give me what was generated by AI and what has been generated by what is the description provided by myself. And you will see that Sydney Opera House was the description was given by me, but real description was this. So the cosine similarity was quite near, which is 94%, which means that I chose the correct one. If one last minute and I want to show something important. So this is my mobile screen. This is right in the action. So if I click on this, it will open up this application. And if I click on get riddles, it will go choose the get riddle, choose the riddle, and it will generate the riddle. If I say an echo, which I know the answer for, so I will say an echo, and you will see that it will try to guess that yes, your answer is correct because I knew the answer. I could choose another riddle, so it will just go and fetch another riddle. It takes a little while to refresh it. Now going to the landmarks, if I go in the landmarks, it will ask me to create like choose the country. So I will choose, let's say, Brazil, and as soon as I chose Brazil, it is going and getting calling my landmark function. It is going to show me the landmark of a famous place of Brazil. So you can see that if I write, let's say, a description, any description, let's say Rio, and it will say, no, this is wrong because yes, I know that this statue is in Rio de Janeiro, but my criteria of cosine similarity is more than 85%, which was 81 over here. So the way, and you can also use the OpenAI service or Azure OpenAI service, as you can see over here. This code base, sorry, I'll just show you something. So this is this exact code base is also on GitHub, but unfortunately, I have not yet publicized it because I'm just working on the documentation of it. So if anybody wants to work with me on this, finalize the documentation, and I'll be happy to share the whole code. So the whole code is way over here. Very basic stuff, nothing super complex. Anybody who is equipped with the knowledge of .NET MAUI can do this. I don't want to take more time unless anybody has any questions. I hope that I'm on time. I've not gone far. Yeah, it looks like it.
Yes, Arafat, thank you so much for this very great session, and you are perfectly on time. So,
Yeah, thank you
Amy,
very much.
you were very excited for this one. Do you have
was.
questions for Arafat?
I do. I'm actually gonna take over the questions just here. Arafat, can you explain to me, one of my outstanding questions around semantic kernel is, if I was, say, using prompt flow, and we can do so much in there with data and calling different things and all of that, where is the connection? Like how would prompt flow work with semantic kernel?
Yeah, there is a native integration of prompt flow with semantic kernel now. So if anybody wants to know like how they can use it, I think the latest Ignite sessions will definitely help them. I'm yet to catch up with all of those sessions because there are so many of them.
Yeah, we all have that issue.
But yes,
yeah.
I definitely know that there is an integration with prompt flow, and the team at Semantic Kernel has done a great job in integrating all of that. So the semantic kernel basically can be considered, as I said, a building block. So when it can be integrated with the other models as well. Like you can bring in your own models, be it Llama, be it Falcon, and also it can be integrated with the prompt flow to see like how they are flowing and how the information is getting flowed.
Fantastic. Thank you. You've answered that really clearly for me. I think that was always just a bit of an outstanding little piece. Like where do they cross over? So yeah, I really appreciate that.
There was one last question for you in the chat. If you could share your GitHub link there.
Absolutely, I will do that.
Okay.
I will
Thank
do
you
that
so much for joining us for this great session, and have a great conference.
You too. Enjoy.
Thanks. So we will be out for a short break, and in a couple of minutes we will be back with our next speaker. See you in a bit.